So I just wanted to give a brief demo of what I built for the uh, hackathon. So as part of the hackathon, I actually added a new uh, reasoning approach in my open source project, OptiLLM. And the approach is inspired by, it's called DeepThink, and it is inspired by the recent work on from Gemini. So if you look at Google's announcement, they announced Gemini 2.5 Pro DeepThink model, which actually improves on existing benchmarks by using uh, inference time scaling. So I looked at how we could actually do something similar with the Qwen model. So you can take a look at the plugin here. So I ended up implementing a couple of approaches from existing papers. So the first one is called Self-Discover Framework, which was a paper from Google back in 2024. And they spoke about how you can use LLMs to discover critical thinking paths or structures from a self-discovery process, and then use those to do COT style reasoning, right? So I implemented the self-discovery framework. And the second thing I implemented is something which is from the Gemini's paper, which is called uncertainty routed chain of thought. So if you go to the original Gemini paper, you'll see that there is not much details in the paper about the approach, but they do mention it in the passing. So the way this approach works is that instead of just selecting uh, multiple trajectories and then doing a combination or a best of n, it evaluates a confidence number. And then based on the high confidence or versus low confidence, it will fall back to majority voting versus greedy decoding, right? So how we implemented in our OptiLLM is that we would actually generate multiple samples using the discovered structures, which are found from the self-discovery process. And then based on the confidence of the model, we'll choose whether to use majority vote or greedy sampling, right? It's very simple to use it in the in your model. So you can just prefix it with DeepThink, and then you can add the name of the Qwen 32B, and it'll just apply the approach. So let me just show you where in the paper. Yeah. So this is kind of what's mentioned in the passing in the paper. So I looked, I couldn't really find any open implementation. So I decided to just implement that in OptiLLM. So this approach talks about, using K chain of thought samples. For us, because we use the Qwen model, we'll just extract whatever is there in the between the think and the think tags, and then use that as the COT, right? Um, Using it's very simple. So if you just go ahead here, you can start the proxy with the base URL from Cerebras, which is for the OpenAI compatible API. And then all you need to do is you'll notice that it will load up the plugins, just like all the other plugins. And then you can just use this as a input to your program. What I did was in my case, because I wanted to evaluate the performance, I actually checked with the AIME 2025 results, and I use Math Arena to do the testing. So I'll just run that script here just to show you how it looks like. So when you run this, when we run this from this harness, it will actually hit the endpoint, and then it'll apply the deep thinking approach and then show you what other things it does. So you can see here that we just prefixed the model with deep think, and it hits our proxy, and you'll notice that it has started the process. So at first it would go ahead and try to use the self-discovery to discover the reasoning structures, and then it found the reasoning structure. Then it would generate multiple samples, and then it will check whether the confidence is low or high, and then based on that, return the final result, right? So in our very quick, we didn't have much time, just a very quick experiment. I could run it only on one particular benchmark, which has around 20 or four items in it. So we found that we can actually improve the accuracy of the baseline model by using deep think. And I have already added this in the proxy, and it is up for release, so you can try it out. Thank you.